So my name is Kasper, and I want to introduce my contribution to Dagger, which is Rust SDK in early alpha. Yeah. So a little bit about me. So my day job is a platform engineer at Luna, and you can reach me on these handles. I'll also share the slides afterwards if you're interested. So what I've done is I've basically built a Dagger SDK from scratch. So that means everything from the code generation to the download of the binary and the SDK itself everything is in Rust. And it is also in a separate library, which I'll show in just a moment. The goal of the project is to get as much Rust native code feeling as possible. So when you're using this SDK, kind of like the other SDKs that you're used to, you're actually programming in that language. You're not programming in some weird DSL that is built around it, but it actually feels like you're building in that language. And that's the feeling I want to implement as well. And also that, when you use this SDK, that you're using regular Rust tooling, you're not using some weird constructs I've built. You are using the libraries you're used to and most familiar with and want to use that fits in your infrastructure. So yeah. And I'm just going to share the repository here. So yeah, this repository is split into 3 different parts. So it's split into the code gen, the core, and the SDK. Probably for you, the SDK is the most useful part, but the code gen, is the thing that actually builds the code that you're using. The core is the thing that is actually handling the download of the binary, just generally all the heavy duty stuff of the SDK. And then lastly, the SDK itself, which is the thing you're probably going to download and use. And, that involves everything in the API. So yeah, there's a little bit of a get started guide here and README, not a fancy blog post or anything, but yeah, that's basically it. And I've also taken the liberty to add all the quick start examples in here as well. So you can go and take a look at that. And there's actually also the Docker file one. So if you're interested in that thing. All right. Moving on. So my demo is actually a little bit different. So I want to take the popular project grep, which is a Rust grep replacement, and basically replace its build system with Dagger. And yeah, here's the project by Burn Sushi. It's quite nice. I highly recommend. And here's my fork, and I've added a little branch where I've done my changes. And I'm going to continue on from here in the terminal instead. All right. So here I've basically added a folder, or rather crate, which is the equivalent of a package in Rust. And for that, I've added a few dependencies. So you can see the dependencies here are Dagger SDK, Aya, Tokyo. You can choose to replace these tools as you want. So Tokyo is probably a requirement, but for example, the error handling, you can choose to use something else if that's your preference. And the way I've structured the demo is here that normally you would just have a main function with all your functionality, maybe a little command line application. In here, I've added a few functions I'll call instead. But I'll just briefly go over the syntax for those unfamiliar with Rust. So basically, Rust works in this asynchronous function way, kind of like Python. So we have these tags as well as unwrapping results. So you might see this question mark operator, and this question mark operator basically means if this function fails, it just returns immediately. So yeah. All right, let's move straight into the first example. All right, so the first example here is basically if you're familiar with the Golang SDK, this is the equivalent. You have the basic connect functions. And as you can see, it's also fallible, this function. So it means it can fail. And you have to handle it in Rust. Rust is very strict about this. Next up, we're just doing the basic hello world. We want to start a container, pull from an image with a few execs, and then printing to standard out. And specifically here, we want the version of the Rust compiler. Yeah, oh, that's not the one I wanted. And I'll just start up here, and it's building the binary, the thing. And you can see here, we start up and I get maybe a little bit more information than I should, but we finally get out the, the compiler version that we wanted to. And it ran a little bit more quick than Rust is used to, and that's because I've pre-cached the results because we don't have all day. All right, up for the next demo. Yeah, so this is a little bit more involved, so yeah, keep on. Here again, we do the connect, but now we actually load the current working directory in. So that's the current directory that the executable is executed from. And I choose now here to actually exclude the target folder. The target folder here is basically the node module equivalent in Node.js, and I don't want that in my build context. And here you'll actually see the first difference to what you're used to in a normal Golang SDK. You'll see that this has a suffix called opts for options. And that's because Rust doesn't support default arguments. So instead, what I've done is I've created two versions. So you have the normal one for the ergonomics, and you have a second one with the options. Yeah, but they both have documentation as you're used to from the other SDKs. Yeah, and we pull the ID, fallible thing you already know. Next up, we're actually going to start up a Rust container. And what we're doing here is we are basically pulling, the Rust image, and we're pulling the latest Debian edition. We're also applying a few execs to get Git installed because this project specifically requires it. And next up, we are mounting the actual directory. So we get the source in and we set the work directory in. Yeah. Right. And lastly here, we actually built the rip grep, and RG is short for rip grep, and that's how you normally execute it if you have it installed locally. So here we just build it, and we use the normal cargo build tools as you would if you used just a regular build system. We also pull out the file because just for fun, I want to pull it into a different image to execute it in. It's not strictly necessary, but yeah. And the task that we actually want to accomplish is we want to load in this docs folder that is in the project, because this docs folder has a lot of entries, and I have a sneaking suspicion that this docs folder is going to mention rip grep. So that's what I want to search for. So yeah. So again, new container, this time Debian by itself. I load in the file. I mount the source from the host, and I set the working directory. So I make sure I'm in the right folder, so I don't scan the entire file system. Been there on that. And last up, I actually execute RG and search for rip grep and print the standard out. Yeah. And I'll just run this as well, and hopefully this will go fast. Yeah, and it's a little bit jumbled up here because of the small terminal, but you can see that rip grep is mentioned a bunch of times here, so that means that it's worked. Right. So the last example I want to show here is I'll go over this quick because it's again a little bit involved, but in here we actually use the async functionality of Rust to do multiple things in parallel. There's some clunkiness here, so excuse the alphaness of it, but here we do the same thing. We load in the source, and here we actually trail over a few different versions of Rust. So now we want to build the project with Rust 165 and so on. And I have to do this little dance here because Rust is very strict about memory. And I spawn the different tasks. I do the things, and I want to get the versions out. So my last step is I basically want the versions of rip grep, and I want to return it. So this is just a regular Rust code, this Tokyo thing. So yeah.
Very cool, Kasper. One of the questions that one of the community had was, how hard was it to create this SDK, and is there something we can improve for people to contribute new SDKs? Because you are one of the first, so we'd love to get your feedback live. And don't be shy.
I think it was actually pretty easy to get started on, especially with the you have 3 SDKs. You have 2 of them that are built in the code generation is built in Golang, and one that is built in Python, and that made it made it so that I had some references for what to actually do here. I'll get into the challenges, a few of the challenges I had in just a minute, but a lot of them I could probably say is related to memory safety in Rust, as you might be able to tell, and implementing the asynchronous things. I also sadly had to use the nightly compiler for the code generation because of a bad choice of libraries, but that's not something that the user is actually going to be bothered with. But all in all, I also still have one hiccup, and you already know it because there's an issue on it, but there's the thing where you can return multiple multiple of these, multiple environment variables, entries, and so on from the same function, and that doesn't map very well into how you've structured, the graph and so on. So there's a little bit of a challenge there, and that's the major missing part. Yeah. And the fun thing is I've actually also implemented the build system for the SDK in Dagger itself using the Rust SDK. So it's dog fooding itself to build itself, which is quite nice. And I've also implemented, if you're interested, I've also implemented distributed caching and, all the kind of things to speed up the Rust build because it's a little bit slow. So yeah, enough about that. I'll just return to the slides here. I probably didn't see it, but you can see there's this SIMD thing and everything happens all at once. So the output here is a little bit garbled, but you can see this SIMD here is mentioned 3 times. So that basically means that it ran sort of at the same time. Yeah. So some of the challenges I had, it should come at some point, the memory model. It also, in an initial version of the SDK I built, you can find it in Rust SDK if you're curious, it was a lot more verbose. And I'll get into that in a moment. But it basically means that the easiest way for me to implement the SDK would make it very bothersome to work with for the user. So I had to jump over some hoops to make that happen. There's also a weird bug I found building the demo. I think it's probably an issue in my code, but if I have a long chain of functions, it couldn't find a file at the last moment. So I think there's some ordering in the way I've structured the code. But yeah. I sneaked around it by building these small blocks of code instead. So you can see you have this Rust, RG, docsource, and whatever else. So yeah. And the last point, which is probably the most major point for me, is like every other language, when you design a library, or an SDK in this case, you have to make it ergonomic for the user. But that also means that usually that you have to take on complexity in the library itself. And this is especially the case for Rust. Rust is very strict about its memory, its performance, and all that kind of jazz. So I have to increase the complexity of the SDK itself and maybe make it a little bit less performant to make it easier to use. And that's a balance you have to strike. I think I'm at a pretty good point now, but like you see with this thing here, there are some things that could definitely be improved. Yeah. So what is next for the project for now is I want to make it more ergonomic to use. So you saw a little bit of a snippet on it, but I went over it quite quick. But the asynchronous way, of running multiple things in parallel is a little bit clunky and relies a lot on the user's knowledge of Rust to be able to work it, use it properly. There's also, I want to add some more options that are existing in the current SDKs. For example, right now you cannot turn off standard out and standard error. It's quite an easy fix, but it's probably something we want. I also want to add the option that you can choose your logging mechanism and tracing and, performance tuning and whatever else you need. And last up, I have taken heavy inspiration from the Golang and Python code generation. And that means that the code generation couldn't be set to be very idiomatic, Rust idiomatic. So there's definitely some tech that I need to clean up there, but that's not really related to the SDK in any way. It's just internally and ergonomics. Yeah, and that's basically it. And you can scan the QR code for slides if you want, and they're also available on my GitHub profile.